Hi guys, if I were an astronaut inside the space station, after letting away this pencil, it will be start to spin and float in the air inside the station because of the absence of gravitational force. Here in my room, if I let away the pencil, it drops down on my desk. And this is the effect of gravitational force. The same phenomenon happens to the air molecules because they have weight and mass, as we had the way to explain in the previous experiment. And then we are under a lot of molecules of air because they are attracted by the earth. And this produces a very great effect of the gravitational force. Because if we consider only the troposphere, which is the first layer of the atmosphere, the layer in which all weather manifestations happen, we consider that upon us we have more than 20 kilometers of air upon us, and this produces a great effect for the weight of the air, for the weight of molecules. This pressure works in all direction, and we can imagine that inside these cylinders there's the same atmospheric pressure which is out. Also the same atmospheric pressure is inside this sack cup, and if I compress this sack cup on the smooth surface of my desk, you can see what happened. It remained stuck because my pressure pushed out the air which was in the concave space, and now the atmospheric pressure which is in the external sides of this cup is trying to enter inside, but isn't possible. I can only lift one side of this cup for allowing to the air to enter inside. We can repeat the experiment after lifting the air go inside. This phenomenon was studied by an Italian great scientist called Torricelli, who studied fluid liquids overall, but who gave the first elements to comprehend the atmospheric pressure. Torricelli, in fact, is the inventor of the first kind of barometers, which was a pipe also called the Torricelli's pipe. And he demonstrated the presence of this great pressure, atmospheric pressure. Another German scientist in 1650 tried to do another experiment. He prepared two hemispheres, also called Magdeburg hemispheres, which was made of with brass. The two hemispheres were so perfectly fit, which was possible after put near one near the other, so perfectly fit, which was possible to expire the air from the valve which was placed in one of the two hemisphere. After closing the two hemisphere and aspiring the air, wasn't nearly impossible to separate, to detach the two hemisphere. And the experiment of this scientist called Otto von Guericke was demonstrated, publicly demonstrated. He prepared the two hemispheres after aspiring the air, the inner air, and he tied on the two external rings of the two hemispheres, he tied 8 horses in which ring, 16 horses. After giving the order to pull, the horses started to pull, but the two hemispheres remained stuck because it was impossible to detach them because of the atmospheric pressure. This is very important to highlight because scientists measured the weight which produces atmospheric pressure, and at the sea level the result was very surprising. 14.7 pounds per square inch, which is equal to 6.7 kilograms per 6.5 square centimeters. This means that our atmosphere has a weight of more than 1 kilogram on each square centimeters. I can demonstrate to you, can explain to you some other element with this example. This cylinder has a base which we can measure the diameters, which is 5 centimeters. If we can calculate the surface of this base, radius by radius, 2.5 centimeters, and the result multiplied by 3.14, we have a surface of more than 19 centimeters. And you have to remember this example because I'll explain some minutes after this example. And now we can repeat the example of the air pressure inside this sucker cup another time. And now we can talk about this pressure which was impossible to enter the air inside this sucker cup. We told 19 centimeters. If the pressure is 1 kilo per 1 square centimeters, we can imagine this effect. I prepared a pack of sugar which has the weight of 1 kilo. To imagine the pressure which our atmosphere is pushing on these cylinders, after putting this pack of sugar, you have to imagine that to explain the correct effect of the weight of our atmosphere, you have to put on this pack of sugar other 17 packs of sugar, because this pressure arises with the altitude. In my town, the altitude is less than the sea level, then not 19 kilos, but about 18 kilos. Next time I'll give another 2 small examples of atmospheric pressure. Bye bye.